South Africa is working to strengthen its electricity system while expanding the role of clean energy in its national mix. In the Northern Cape, the Redstone Solar Thermal Plant is part of that shift, a renewable project developed through South African and Chinese cooperation, now delivering clean power into the national grid. As many African countries navigate the global pressure to transition faster, often without sufficient financing or acknowledging Africa's low contribution to global emissions, projects like Redstone highlight what a balanced, practical transition can look like, one that uses local resources, builds technical capacity, and supports local communities. This week on the program, we explore how Redstone works, the partnership behind it, and what clean, reliable electricity means for South Africans and for the continent's energy future. I'm Beatrice Marshall. Welcome to Talk Africa. Behind the clean power generated here at Redstone is careful engineering and advanced technology. To help us understand how it all works, we begin with one of the engineers on site. We're now joined by Clayton Michael Rudd, the General Machinery Regulator 2.1 plant engineer. Clayton, thank you for joining us. Now, from an engineering perspective, let us start off there. How does the Redstone solar thermal technology work, and what makes it different from other solar power energy?
Thank you so much for having me. Okay, so basically how the Redstone CSP 100 megawatt solar tower works, I'm just going to explain to you how what it exists for. So first of all, we have a solar field which exists of heliostats or mirrors. Then we have a solar tower or a tower receiver which receives the sun rays from the solar field. Then next thing we have is a water treatment plant. So the reason for the water treatment plant, because usually what we call raw water, like the one we consume at home, it's having some impurities. So we have to treat that water so that we remove all those impurities so that it cannot damage the equipment or valves, and also to create a cleaner type of steam. After the water treatment plant, the next step, the next area we have basically, it's what we call the steam generation system. Then we also have what we call the turbine and generator system. And we have the transformer to step up the energy and send it to Eskom. And after the steam has been used, we then basically have the air-cooled condenser or ACC, which then cools the water, the steam down again, puts it back into water, and it then goes back to the water treatment plant. So having explained what it exists of, so now I'm going to explain how it works. So basically, the mirrors, like you would take a magnifying glass and you would concentrate it on a piece of paper in the sun. The paper would set alight after a while because of that intense heat that's concentrated in a small area. So similar concept, it's just here that we just want to heat it up there. So we heat up the solar receiver. The solar receiver in turn heats up to about 565 degrees Celsius. We send up the molten salt via pumps. The molten salt then heats up to about 555 degrees. Right. The molten salt mixes with the water. It becomes steam. The steam we send to the superheater, it then becomes superheated steam. The superheated steam in turn spins the turbine. The generator generates electricity. And then the step-up transformer, as I've explained, then would send it to Eskom people. And then it's cooled down.
So from an engineering perspective now, what does a project like Redstone mean for South Africa's energy potential?
Redstone can really be a game changer, in my opinion, ma'am. As I've explained before, let me just go a little bit deeper. So the way in which it generates electricity, also it has what we call the molten salt storage system. So just to explain it basically to the layman's person, it's like, for example, if we take the molten salt, it can also be what we call thermal energy storage. It can be what they call charged during the sunlight, and then it can be kept inside a tank where the energy storage will remain, and it can be used at a later stage. So the concept there, basically, to put it easy, is, for example, if we take our power bank, we charge it at home or the office later on when we go on the road, we can use that energy that is stored to charge our phone or laptop. So this is the same. So Redstone can obviously generate also after sunset for about 12 more hours. So it can generate during nighttime as well. So your normal PV project, it can only generate during daylight. So this is the difference that the Redstone project brings along. It can generate up to 100 megawatt, which is equivalent to almost 200,000 households. And it can do it on a 24-hour basis, obviously in the summer months.
This was a collaboration between South African and Chinese partners. How did that come about and what was it like?
Look, I must say the Chinese people, they've come, they have collaborated with South Africa to build this power plant here. One of the reasons is, as you might be aware or might not, that we do have a challenge with electricity or power in the country. So this renewable project collaboration, it was where Chinese people came together, South African engineers, Chinese engineers, everyone did their part to ensure that the project has been constructed, commissioned according to the specifications and the design.
So when you talk about this project, though, you know, it is quite a new technology. Talk to me about the skills transfer to the local community.
Okay, I must say skills transfer was one of the success stories, because many people, it was their first time working in a renewable project. For others, it was the first time working in a CSP project, and especially for some other people, for working at heights, some skills, some operators, they received some training, working on a scaffolding, for example. Some persons learned the skill of assembling the mirrors, assembling the steel structures, putting together basically everything according to what the specifications say. Another skill, I must say, that took place, some people even learned how to read drawings here, which in the past might not have been the case. Another skill might have been discipline. I must say, one good thing, the Chinese co-workers, they are really disciplined. When they say this time, it really starts on time. So with timekeeping, it's really some skills it had taken place, ma'am.
In terms of the technical capacity, what kind of technical capacity now exists locally that wasn't there before?
I would say some people now, what they've done also, they've trained some guys how to operate in the control room. So that wasn't there in the local area before. Another skill was basically in the solar field, how to maneuver those mirrors, fault finding, troubleshooting. Some persons, some welders were learned how to improve their welding skills. Obviously with the complex items, it was obviously the highly skilled welders done. The smaller items like a handrail or another thing that might not need some pressure test or something. So those skills are now in the area. Some people are really have been exposed to big industry, how things are done, how it should be done safely, correctly, and as I said, according to the design, drawing, and specification.
So Africa is rich in natural resources, in solar, in wind power, but we haven't seen projects such as Redstone across the continent. Where is the gap? What is the missing link?
I really think, ma'am, that we do enjoy some of the best weathers in the world, in Africa. We are blessed with sunshine, nice wind speeds, and very, very blessed weather. So it would really be nice. We do have the natural resources, we do have the space, we do have the manpower. The only thing we need is some investors to really invest in Africa, and also if we can get partners like SEPCO 3 that can come collaborate with us, show us how to install the equipment, operate the equipment, and then obviously we can do the rest, and really Africa can benefit in this manner if we just have that, some foreign investment.
So that's the engineering behind how Redstone works. But beyond the technology, this project is also about people, skills, and long-term impact. To understand that broader vision, we are now joined by Wang Jiyo, the Deputy Project Director, Redstone Project. Mr. Wang, thank you very much for joining us. Let me start by getting your interpretation of what goes on here. How has working with Redstone on the Redstone project shaped local engineering capacity?
It's a big step for the South Africa energy, since it's the first large tower concentrated solar power plant. When connected to the grid, it's a major win for the South Africa renewable energy. Cycle 3 trained more than 200 local engineers and partnered with over 50 small and medium businesses. This helped those companies build skill in construction, equipment supply, and more creating a local supply chains and technical support network in the Northern Cape.
So what aspects of the technology have been most transformative or challenging for your team?
For the molten salt storage, let us generate power 24/7. It fixes traditional solar problem of only working when the sun rises, turning the solar thermal into the steady source with the renewable plus the controllable solution. We faced several challenges during our project. For example, the solar thermal technology is complex. Work on the high tower was a risk. And finding the resource was very difficult due to the site is far from the major cities. Additionally, we have to integrate 3 key technologies: the solar concentrating, molten salt storage, and the grid connection. This main challenge was aligning the power plant with the national grid, the voltage and the load response.
Can you talk to us about job creation and upskilling for South African workers through this collaborative project?
For the job rise, we create over 1,800 local positions, covering construction, commissioning, operation, and maintenance. It being great for the young people and graduates. Importantly, during the project construction, we focus on employing the people from the local area and the nearby area. We also organize the training program to enhance their skills, so they can find some work when the project completion.
What does this project mean for South Africa's broader electricity goals?
Redstone generates 480 gigawatts of the electricity annually, cutting 426,000 tons of the carbon emissions, and supporting South Africa 2030 carbon reduction target. Thanks is the 12 hours molten salt storage. It filled the peak electric gaps, reduced load shedding, and lay a solid foundation for the future new energy projects.
Mr. Wang, thank you very much.
Thank you.
Well, from engineering to international partnerships, we've seen how Redstone was built. We'll now take a short break, and when we come back, we turn to impact, what this project means at the top and what it means on the ground with the community. Stay with us. Welcome back to Talk Africa. To understand Redstone's role in South Africa's clean energy transition, we're now joined by Romano Ninon, Project Director of the Aqua Power Redstone Project. Romano, thank you very much for joining us. Let's start off with South Africa's transitioning from fossil fuels to renewables. Now, as South Africa increases its clean energy capacity, how does Redstone support the country's transition to a more sustainable and reliable energy source?
So the Redstone project, in terms of our transition from our conventional fossil fuel power plants in South Africa, it's quite significant because number one, the technology, it's a very, how can I say, it's a young technology, but also very interesting technology. And the technology allows us to extract the energy from the sun and put energy onto the grid without having to burn fossil fuels. The way we extract the energy is it reflects onto a heliostat field. In our heliostat field, or solar field as we call it, we have 41,260 heliostats, and that's mirrors that concentrate the energy onto the receiver. The CSP tower technology is quite young in the world, and to have one of them in South Africa, and I mean in Africa, is quite significant. I think in South Africa we only have two, and Redstone is the largest one that we have in South Africa.
Mm-hmm. So, the continent is facing pressure to move rather quickly to renewables despite large energy deficits. From your perspective, though, what does Redstone show about the importance of projects such as this one, that balance clean energy technology with local needs and resources?
It's quite significant because the facility, even though it can only supply 100 megawatts onto the grid, powering almost 200,000 households, that's quite significant. But what makes it more important is the fact that we can do this by, again, extracting energy from the sun and having dispatchable power, meaning that on demand. We can supply electricity on demand to our dispatch center, South Africa. What makes it more significant is that we can do this on a 24-hour basis, right? So if the sun is out, we can produce. And if we have clouds or if we have rain or even during the evening, we can still produce for using our 12-hour energy storage capacity.
Africa is still working to provide energy to millions of people across the continent. What lessons from Redstone can be applied to future clean energy and grid modernization projects across the continent?
Initiatives like this to make people aware that there are other alternatives to conventional fossil fuel, and also to make people aware of the benefits of a project like this, right? In this location where we are now, it's in South Africa. The Northern Cape is seen as a remote location, but we've successfully constructed a large-scale project like this. And also the impact that we have on the local community. I mean, this facility is going to be operated for 25 years, so that is an opportunity for job creation. And a young technology like this and a complicated technology like this can be and was successfully built in Africa.
What impact, though, do you see this having? You've talked about the local community, but what impact do you see this having on South Africa's broader power grid?
In terms of the technologies that we're using, the most significant part is the thermal storage capacity of 12 hours, meaning that for 12 hours, our energy is dispatchable, it's available on demand, right? And I'm sure there was a lot, I mean, in the media over the past few years, there was a lot of talk about load shedding. So what Redstone does, it assists in making our grid more stable, right? So if fossil fuels power plant cannot provide what we need, Redstone can provide what we need on a 24-hour basis.
Thank you very much, Romano.
Thank you.
Now, beyond technology and strategy, the true measure of a project like this is its impact on ordinary lives. For this perspective, we now turn to a member of the local community who also works at the Redstone Concentrated Solar Plant. Fabricius Jacobs is the Human Resource Officer at the Redstone project. He's also a community member here. Fabricio, thank you very much for talking to us. Now, tell me about the electricity situation before a Redstone project came into place here.
Before Redstone came, we had regular intervals whereby electricity would be cut for 4 hours, for 6 hours. So there was different stages. Stage 1 would be about 2 hours, going up to stage 8, which would be 6 hours or 8 hours. During this time, you had no access to electricity, meaning your fridge is off. All those perishable goods become spoiled, leading to fridges that start smelling. So that's the first inconvenience that load shedding created. The second inconvenience that load shedding created for us is your normal daily life. You couldn't plan. I mean, sometimes you would wake up and have to go to work, then you can't wash, you can't eat. There's children living in the house that also need to go to school. It also affects them. And I think one of the biggest things is when it comes to their studies as well. It's quite difficult in today's ages to be studying in the darkness by a candle. So this is the main issues that load shedding created. One, with our food. Number 2, with our studies. Number 3, with our daily routines. It's difficult to plan without electricity. With the phones as well. I mean, a phone is a critical device. So if you don't have access to your phone, you can't get called. Job interviews, you can't get called if someone is sick, a family member. So that's also a problem that it created. We were not reachable. The networks would also be off.
So what does having stable electricity mean for hospitals, for schools, for clinics in the area?
You know, within the community, there's a lot of people that run businesses from their house. I'll take you down to the lower level businesses, a granny that just sells ice blocks, or someone that sells cool drinks. So during load shedding, they couldn't do that. But now that we have a stable grid again, they are able to continue with their spaza shops, as we call them in South Africa. They are able to continue with their small businesses. What it also did is, like for me personally, I do online studying. So I have continuous access to the internet, continuous access to my laptop, which means I do not need to go to the university. I can attend my classes, I can submit my assignments. So yeah, that's what it helped us with.
Mm-hmm. What sort of opportunities, though, has the community experienced as a result of the project being here?
First of all, it created a lot of employment opportunities. I don't have the exact figures, but it ranges from 1,200 to 1,800 local jobs that Redstone created for the community. I personally was a beneficiary of employment from Redstone. I got appointed initially as an HR administrator in 2020, and I got a promotion to an HR officer dealing with recruitment. So our primary responsibility was recruiting local employees. Say, for example, if we need an electrician, we will first look locally. If we need a safety officer, we will first look locally. So general workers, during our peak in construction, we had about 1,200 that came from the communities, creating employment for about 3 years. You know, some people were on site till today for 3.5 years. So there was a lot of employment opportunities, a lot of business opportunities as well. In front of our site, there was containers parked, whereby the people from the community would come and sell some sweets, some cold drinks, and some food to obviously all of the people working there. So it created a lot of jobs and also a lot of business opportunities.
Mm-hmm. So looking forward now, because you've seen the past during load shedding, you've seen the stable electricity in your community. What are your expectations personally, and what are the expectations of the community?
So we, hope that we do not fall back to load shedding, and it hasn't happened for quite a while now. The second thing is the project is now during the operation and maintenance phase. We hope that there will be new opportunities granted to the community, to engage in longer term projects, because the anticipated lifespan of this project is about 40 years during operation and maintenance. So, for example, the minibuses on site and the buckies on site belong to local community members. They actually rent it to the project owners. So we are hoping that these people can benefit on the long term, secure 15-year contracts, 10-year contracts with their minibuses, with their vehicles. We're also hoping that as a community that they will now invest in the community, help us with maybe ECD centers, early childhood development centers, maybe help a few NPOs. So there's the longer term goals that we hope that the project will help us with.
Mm-hmm. So beyond the direct employment and the direct business, I want to hear from you what other opportunities that the project has brought to the people individually and to the community.
So besides employment and besides business opportunities, there was about 40, if I'm not mistaken, young people that we took directly from high school, from matric. So these people were sent to Dubai for 3 months to go and study how the plant. This is the first plant like this in South Africa. So we send people from straight out of school to Dubai for training, and they are back now on site working there. So we've created new skills in the community that was not necessarily here, and we're hoping that these beneficiaries, the students that went to Dubai to gain the skills, can now come back and also transfer it to the ones coming from schools now.
Do you feel that this project has changed the way people perceive renewable energies and the way people are looking at the future?
I think so. Mine has personally changed. The project has significantly changed my life in terms of employment, in terms of business, and in terms of skills development. So as a community, we would be open to future projects like this because of the fruits that I've just mentioned.
All right, Fabricio, thank you very much.
Thank you, Madam.
Redstone shows how clean energy, international cooperation and community impact can come together in one project. As South Africa continues its transition, the lessons from here resonate far beyond the Northern Cape. Well, that's all we have time for on this edition of Talk Africa. A big thank you to our guests, Clayton Michael Rudd, General Machinery Regulator 2.1 Plant Engineer, Wang Jiyo, the Deputy Project Director, Romano Ninon, Project Director of the Aqua Power Redstone Project, Fabricius Jacobs, Community Member and Human Resource Officer at Redstone Project. Remember, you can be a part of this conversation through our social media platforms on Facebook and X, and you can watch this and other editions of Talk Africa on our YouTube playlist. Do join us again next week for more at Talk Africa. From me, Beatrice Marshall, and the team here in the Northern Cape Province of South Africa, until next time, it's goodbye.